Hey guys, welcome. Yeah, so problem 4 here, and there's a lot of information to process about it, but you can quickly summarize it in this way, which is that you're told the internal temperature of the potato at time t equals 0 is 91 degrees Celsius, and that's also summarized by what you're told here. And we're also told that for t greater than 0, the internal temperature of the potato is greater than 27 degrees. And finally, we're also given the rate of change of the internal temperature. That is, we're given h prime or dh dt. Yeah? Okay, cool. In part A, what we have to do is use a tangent line to the graph of h at t equals 0 to estimate the value of h at t equals 3. So first, we need to come up with the equation of the tangent line to h at t equals 0. As with all tangent lines, we can write the equation of the tangent line in point slope form as y minus y1 is equal to m times normally x minus x1, but here t minus t1, right? Okay, cool. The independent variable is t in this case. And the point that we're given, t1 comma y1, is equal to 0 comma 91. Yeah? So our equation so far looks like y minus 91 is equal to m, which we have to figure out, and m is going to be h prime of 0, right? Because we're looking at the tangent line to h at 0. But m is going to be h prime of 0, and then we'll have m times t minus t1 is 0, so just m times t, right? Okay, cool. We just have m left to figure out. Now, since dh dt or h prime is given by this here, we see that h prime of 0 will have to be equal to negative a quarter times, it's tempting to write 0 minus 27, but this is h, not t. So we need to figure out the value of h at t equals 0. And at t equals 0, we're told that h is 91. So that's what we plug in here, 91 in place of h. Because at 0, h is 91, right? When t equals 0. And then we have minus 27. And this here works out to be negative 16. So that's what m is. Yeah? Okay, cool. So we have that y is equal to negative 16 times t, m times t, and then plus 91. All I've done is I have added 91 to both sides of this equation, right? Okay, cool. So since our tangent line has equation y equals 91 minus 16t, then we know that at t equals 3, the estimate of the value of h will have to be y equals 91 minus 16 times 3, which I believe gives us 91 minus 48, which I believe is 43. Yeah? Okay, cool. That's it for part A, and on to part B. What does part B say? I believe part B is going to ask us if our estimate found in part A is an overestimate or an underestimate. And you know that that's going to be about the concavity of H, right? Okay, cool. So first, let's carefully read part B. And it says, it says use the second derivative to determine whether or not our estimate in part A is an overestimate or an underestimate of the internal temperature of the potato at t equals 3. Now, we have dh dt here, so we know that this guy is just a second derivative. So we see that, what a poor d. We see that d squared h dt squared will just have to be the derivative of the derivative, so the derivative of what I just circled. And that'll have to be negative a quarter times dh dt. For some of you, when you're finding the second derivative, it might be useful to distribute this negative a quarter to this guy and this guy, and so that you could easily see that this will be the second derivative. Now, since we already know dh dt, we can't leave the second derivative like this. We should simplify it a little bit more. So we write negative a quarter and then times dh dt, which we know is negative a quarter times h minus 27. So a very simplified version of our second derivative will have to say a 16th and then times h minus 27, right? Okay, cool. Now, crucially, we're told that when t is greater than 0, h has a value greater than 27, meaning that this will have to be greater than 27 when t is greater than 0, right? And so then, since this will have to be greater than 27, anything bigger than 27 minus 27 is going to be positive, and then times the 16 is still going to keep it positive. So what we know now is that the second derivative is positive for t greater than 0. So then we can determine that our estimate in part A is an underestimate. And this is why. Because if your second derivative is positive, it means that you're a function that is concave up. And if you draw a tangent line to any function that's concave up, anywhere you draw the tangent line is going to give you the tangent line is going to give you values of the function that will be underestimates of the actual values of the function in blue. The actual values of the function h are going to look like what I have in blue, and the tangent line is going to give us values that are clearly at all places below the actual value, except for the point of tangency, right? So that's what you say, basically. You write what I wrote in red here, and then you summarize what I've just told you. All right, cool. So that's part A and part B, and let's move to part C so that we can be done. All right, so let's see. Can I delete this? Yes. Part C. Part C says the following, which is a lot. So part C says like all this junk. And what is it really? It's basically telling us that there's this other function that can give us the internal temperature of the potato, and it's called g, and its derivative is given by this guy. And so it's saying find out what g is and then evaluate it at 3, basically. And we're told that g of 0 is 91. And so because I need the space down here at the bottom, I'm going to summarize what's written here up top and then get rid of what I have here, yeah? Okay, so what we have to summarize is that dg dt is equal to the negative of g minus 27 to the 2/3 power. And equally importantly, we know that g of 0 is equal to 91. And we also keep in mind that we have to, once we find g of t, we have to evaluate it at t equals 3. Yeah? Okay, cool. Now, we're going to solve for g of t by a method called separation of variables. And I already have a lot of videos on separation of variables, so feel free to check that out. It's a differential equations method, but obviously you're taught it in Calc AB and BC very lightly. But yeah, when you solve differential equations, you either have a general solution or a particular solution. And you can only get the particular solution if you're given an initial condition. That is, you can determine the constant that comes with solving this differential equation only when you have an initial condition, which we do here. Yeah? Okay, cool. So let's first start by separation of variables, which, as the name literally says, you start with by separating the variables. So that'd mean that we write dg divided by, let me use my ruler, safe, dg divided by, and it'll be g minus 27 to the 2/3 power, and then the right side will then have to be negative dt. And now we've got the variable separated. And in a separation of variables method, once you've got the variable separated, you always take the integral of both sides. So there it is. Now, the integral on the left is easier done if you write this guy in the numerator, or it's easier to see if you do that. So g minus 27 to the negative 2/3 power, right? And then dg, and the right side is already easy to solve. It's negative t plus c. Now, notice that since I have an integral on the left side, just like the right side, I have a plus c from the left side and a plus c from the right side. So I have two constants. But I'm just going to lump them into one constant and just write a plus c on the right side. Yeah? Okay, cool. Now here, by using the power rule in reverse, we can find the antiderivative on the left side, and it will be g minus 27, add 1 to the power, so we get 1/3, and so divide by 1/3, which is same as multiplying by 3. And then, as I said, plus c, but we've already combined the c from the left with that guy, right? So we have minus t plus c. And now we need to determine this constant c, and that's where this information comes in. So we know that when t is 0, g is 91. So we can write that we've got 3 times 91 minus 27 to the 1/3 is equal to negative 0, which is just 0 plus c. So I should just write a c on the right side, right? Okay, cool. And that's again because I've plugged in a 0 for t there, yeah? Okay, and remember, 1/3 power means cube root, and 91 minus 27 is 64. So this is saying the cube root of 64, which is 4. So 3 times 4 is 12. So that's the value of c, yeah? Okay, cool. So then, now we have this, which is we have 3 times g minus 27 to the 1/3 power is equal to negative t plus 12. Or better yet, on the right side, 12 minus t. And our goal is to solve for g, right? So we get g of t. So to solve, first we need to divide both sides of this last equation I wrote by 3, right? So we divide by 3 on the left and on the right. So 3 there. That was poor. 3 there and 3 there. And here we can cancel these guys. And then it's pretty clear what we should do next. Next, we should take this resulting equation and cube both sides. And when we cube both sides, on the left side, we get g minus 27 to the 1/3 cubed, which is just g minus 27. And then on the right side, we get 12 minus t all divided by 3. I guess I should have used a ruler. All divided by 3 cubed. Yeah, okay, cool. You'd hate me as your math teacher because I'm like very specific about neatness. Anyway, there it is. And so then all that's left to do with g is, to get it by itself anyway, is add 27 to both sides of this last equation. So finally, g of t is equal to 12 minus t divided by 3. Yes, I'm laughing at the ruler use, dividing by 3, and then cubed, and then plus 27. There we are. And the last thing we got to do is figure out what g of 3 is. And so that'll be 12 minus 3 is 9. 9 divided by 3 cubed, and then plus 27. Wait, 9 divided by 3 is 3. And then 3 cubed will give us 27. So that's 27 plus 27, which I believe is 54. Yeah? Okay, cool. That's it. And keep watching parts 5 and 6, or problems 5 and 6 to come. Take care.